I'm Patty Simpson with Simpson Math. Let's use the central limit theorem to help us solve some problems. A researcher finds the mean price of a movie ticket in the United States is $10.20 and the standard deviation is 70 cents. So we're talking about the entire population of the United States, all the movie theaters there. The mean ticket price is $10.20 and the standard deviation is 70 cents. Sample means are calculated for samples of size 49. So we go out to movie theaters and we gather a sample of 49 movie theaters and we collect all the prices, the ticket prices from those 49. And then we add them up and divide by 49 and we find the mean of that sample. And so we do that here, we found a mean, we find another sample of 49 movie theaters, find the mean of those tickets, and do that over and over again. And each one of those new sample means that we've created or that we've found, we use to create a new distribution of sample means. So we have a new collection of data that is just the sample means. And that distribution is what we're looking at. And we want to know what is the mean of that sampling distribution of sample means. So this new distribution that we've created of just sample means. What's the mean of it? What's the average of it? Well, the central limit theorem tells us that the average, the mean of our sampling distribution of sample means, remember that X bar is for the sample mean and the mu is for the mean. So the mean of our sample means is equal to the population mean. That's what the central limit theorem tells us. So that tells me that the mean of my new sampling distribution of sample means is equal to that same $10.20. Then I want to know what's the standard deviation of the sampling distribution of sample means. Well, again, the central limit theorem tells me that the standard deviation of the sample means is going to be equal to the standard deviation of the population. We're going to take that standard deviation from the whole population and divide it by the square root of the sample size. So in this case, my standard deviation of my entire population is 70 cents, 70 cents. And the sample size is 49. So I'm going to take the square root of 49. Now we just do a little math. That 70 cents is the same as 7/10. The square root of 49 is 7. 7/10 divided by 7. We'll just leave the decimal and 7 goes into 7 one time. So it's our standard deviation there is going to be 1/10. So in our distribution that we've created of sample means, we know that the mean of that distribution is $10.20 and the standard deviation is 10 cents. We also know that it is approximately normal. The central limit theorem also tells us that our distribution is approximately normal. So if we were to draw that distribution, that sampling distribution of sample means, it would look something like this, with $10.20 right in the middle. And that $10.20 is going to be the peak of my distribution. It's going to be the mean, the median, and the mode of my distribution. Then the standard deviation is 10 cents or 1/10. So we're just going to count by that standard deviation. So I'm going to go up one standard deviation and I'm at $10.30. Count another standard deviation, I'm at $10.40. Count another standard deviation and I'm at $10.50. I'm going to count backwards as well, so I go below the mean or below average. 1/10 would be $10.10. Down another standard deviation and I'm at $10. And down one more, I'm at $9.90. Now this, because it's approximately normal, I know that each one of those standard deviations, there's an inflection point, and I also know that it's symmetric on both sides of my distribution will be the same. So it looks something like this, where I connect my little dots, and I have a normal distribution, a bell-shaped curve, where I've collected movie prices from groups of 49 movie theaters, found the mean of those movie theaters and put them on there. And that data looks something like this. Now, we're going to answer this next question using that information. A mean is calculated from a sample of 49 movie theaters. What is the probability the sample mean is less than $10? So we have gone out and gotten a sample of 49 movie theaters, found the mean of those movie theaters, and we want to know what's the probability that that sample mean, which is part of this distribution, it belongs here as part of that data. We want to know what's the probability that it's going to be $10 or less. So we're looking for this area under the curve. We're looking for that probability. How much of the area under the curve is there below $10? Well, because this is a nice normal distribution, we can use the empirical rule to help us. So let's do that. We know that 95% of our data, we know from the empirical rule that 68% of our data is within 1 standard deviation. We know that within 2 standard deviations is 95%. And that's kind of the one we need here, because this $10 is out 2 standard deviations. So we know that 95% of our curve is there within 2 standard deviations. Well, that means that since the whole distribution makes up 100% of our data, or 100% of the area under it, we know that on the outsides then, if we subtract off that 95%, then we have 5% on both ends. So I'm taking 100%, the entire distribution, and I'm subtracting off that 2 standard deviations, the empirical rule that tells us that 2 standard deviations, to get the 5% on the ends. But notice I don't need both ends. I'm not looking at this end, I'm just looking at that end. Because a normal distribution is symmetric, that means this side is the same as that side. So I'm going to split that 5% in half to find the percent there on that end. So I'm going to take 5% and divide it by 2, or split it in half, to get that 2.5%. So underneath the curve here, this is 2.5% of the area under the curve, or the probability that we get a sample mean that is less than $10 is only 2.5%. So there's the central limit theorem in a nutshell. The mean of your sampling distribution will be equal to the population mean. The standard deviation of your sampling distribution is the standard deviation divided by the square root of your sample size. And you can use the fact that it's a normal distribution to help you find the probability of where your mean, or what your mean will be. Math Made Simple is Simpson Math. Thanks for watching.